Hello, math students. Today we're going to be going over the direct variation lesson. We're going over the tutorial, practice, and mastery tests like usual. And if you follow along, do everything I do, I promise it'll make a lot of sense. Now, if you remember from previous lessons about graphing lines, if you understood those lessons and understand how to graph lines well, then you're going to do very well on this concept, because basically any direct variation relationship forms a line. And so let's go ahead and do a little bit of warm up talking about drag the tiles to the table to classify the functions as linear or nonlinear. So which of these would form a line, which of these would not form a line? Okay, so let's go ahead and take a look. From the graphs, it's pretty easy. This one's a line. Okay, so that one's a line. This one is not a line. Okay. That's pretty easy. You can see that forms a line, whereas this one is this V shape is not a line. It looks like kind of two parts of a line, but it's not a line. What about from the equations? Which of these would you consider a line? Well, this one's a line. Notice this equation is y equals, you can consider this 1/4 x, where the slope would be 1/4 and the y-intercept would be 7. So this would form a line. This one, however, would not, because notice the x has x to the power of 2, x squared. In this case, that doesn't produce a line. In fact, it produces like a U shape. You're going to learn more about these types of graphs later on, but for now, just know that this is not linear. If you were to graph it, it would not form a line. Okay, now what about these groups of coordinate points? Well, when I look at these two lists, I notice that the x coordinates just go up by 1, right? -1, 0, 1, 2. Same with this other list, -1, 0, 1, 2 for the x values. Now, are the y values increasing by the same amount or decreasing by the same amount each time? Well, in a line, it should be the case, right? Notice the y values in this first list, that the y value goes from 6 to 1. So subtract 5, essentially. And then 1 to -4. Well, that's subtract 5 as well. And then from -4 to -9. Well, that's subtract 5 as well. So that shows that it is essentially decreasing at a consistent rate. In other words, it maintains the same slope throughout. This would form a line. However, this group is not a line. Notice from the first point to the next point, it's increasing by 1, but then the next point, it's increasing by 4. And then the next point is increasing by 8. So you can see here, this is non-linear. If you were to graph these points, they would not form a straight line. Okay, so let's go ahead and move on. And we're going to learn about direct variation. Now, direct variations, they do form a line, but they form kind of a special kind of line. Well, it's not that special, but basically it goes through 0, 0. In other words, the y-intercept, the b, when we say y equals mx plus b, the y-intercept is always 0 when you're dealing with direct variation, but it still forms a straight line. So those are the main things, that it's a straight line and its y-intercept is 0, right? So that's why this blue line is direct variation, but this red line is not direct variation, because the red line, you can see here, its y-intercept is 4. But this one, the blue line is direct variation. Its y-intercept is 0. So direct variations are always lines that have a y-intercept of 0. So that's kind of key. Let's go ahead and move on. All right. Here, meet me here on page 11. Here we want to move this blue line so that it lines up with all these points. So how do we do that? Well, we just need to change the slope. If I'm looking here, I can kind of see from one point to the next. Let me grab my snipping tool here. I could see from one point to the next, what's the slope? Well, the slope is rise over run, right? So what's the rise? The rise is 2 units. So we rose 2 units, then run 4 units. So when I calculate the slope, that's the rise over run. So that's 2 over 4, or in other words, 1/2. So I know the slope that connects these points is 1/2. So when I put in my m, my slope, I'm going to put 1/2 here. 1 over 2. Well, they won't let me put 1 over 2. So they want it as a decimal. So what we're going to do is we're going to call it 0.5. 0.5 or 0.5 if you like. And you can notice here that now the blue line correctly goes over those points. You may be wondering, how'd you get 0.5? Well, if you do 1/2 in your calculator, 1 divided by 2, that gives you 0.5 as a decimal. So one decimal that you kind of should have in mind is that whenever you see 0.5, that's the same as half. Half is the same as 0.5. You should be able to change 1/2 to 0.5 and just know that those are the same thing, all right? That's one decimal conversion you should always kind of have memorized, I would think. But if you don't have it memorized, you could always divide. 1 divided by 2 gives you 0.5 in your calculator. Okay, or 0.5. All right, now meet me here on page 14. We're going to see which set of ordered pairs corresponds to direct variation. So two things. One, it should form a line. So the group of points should form a line. And also that line should have a y-intercept of 0. In other words, when you do y equals mx plus b, the y-intercept, should be 0. So let's go ahead and figure out which of these groups of coordinate points would form direct variation. Now, one kind of way to think about it, and this kind of helps me, is direct variation is always written as y equals and then just mx. Okay, the plus b, well, the b is always 0 for direct variation. So for direct variation, you don't have to put that plus b because the b is 0. So it should be written as y equals mx. They also may write it as y equals kx, where k is some constant. But basically this k here is the same as your slope. All right. So one way to look at it is what would be my m or my k, either way, when I see -2 x value and then +2 y value. So if I look at this and I say, well, 2 is my y value and -2 is my x value, what would be the value of k here? Well, I could solve for k and I could see, well, I could divide both sides by -2 here to solve for k. This gives me that -1 is k. Okay, so for this one, the k or the slope is -1. Okay, so the m or the k or the slope, in other words, is -1. I don't know why they switch from m to k, but just keep in mind that that is the case and you will see it like this. So that's why I'm kind of showing it to you as well. Well, would k be the same here? Well, no, it wouldn't, because if I take this -1 and I multiply by -1, that doesn't give me 3, does it? So notice it doesn't keep the same slope throughout. So that tells me that this is not direct variation. Okay. That's not direct variation there. Okay. Now let's take a look at the next one. Actually, yeah. So if I look from here, from this x value of 6 to this y value of 6, what is the value of m here? So what's the, what are we multiplying by? Well, in this case, it's 1, right? Because 6 times 1 gives me 6. Well, is that the same here? Well, no, 4 times 1, that should give me 4, not 3. So that tells me that's not correct either. What about for this next group? Well, 1, I'm looking at the last point here. 1 times what gives me 5? Well, times 5, right? 1 times 5 is 5. Does that work here? Yeah, it kind of does, doesn't it? 0 times 5, that gives me 0. So that works there. So that could be a k of 5 as well. Here, 0, 0, it doesn't really tell me what k should be in that case. Does that work here? -1 times 5 gives me 3? No. So it needs to be the same k value for every single coordinate point. So that means it must be this last one. And let's just double check. -4 times what gives me 4? Well, -4 times -1 gives me 4. Does that work here? -1 times -1 gives me 1? Well, yes, it does. 3 times -1 gives me -3? Well, yes, it does. So that tells me that this group must be direct variation, okay? Because multiplying by the same constant to go from the x value to the y value on every single coordinate point. So this group here, if you were to graph them, you would see basically these points line up, and that line would go through also 0, 0. That's the thing with direct variation. It should always go through 0, 0 as well, okay? So it needs to be a straight line and go through 0, 0. Okay. Let's go ahead and go to page 16, and we're going to see which of these are going to be direct variation or not, okay? Well, and also what's the value of k? Well, when I look at these, let's go ahead and I'm going to look at this first group of points here. -5 times what gives me -10? Well, -5 times 2. So this shows me a k of 2, okay? Is that the same here? 2 times 2 gives me 4? Well, yeah. Is that the same here? 3 times 2 gives me 6? 6 times 2 gives me 12? Yes. So it has the same k value throughout. So that tells me that, yes, a k value of 2 is what's happening here. What about for this second? Here we're looking at a graph. Would this produce a direct variation? And if so, well, what would be the value of k or the value of m? Well, let's take a look. I can see that, do these points perfectly line up? It appears that they do, right? So these do form a straight line, but does that straight line go through 0, 0? No, it does not. So would this be direct variation? No. Even though the points form a straight line, for direct variation, it needs to go through 0, 0. So no constant of proportionality is what we want to say there. Now, what about this last group? Well, we can go ahead and see what would be the value of k for this first coordinate point. Well, this one's a little bit trickier because -2 times what gives me -3? Well, that's kind of tricky. It'll be a fraction, won't it? But we can go ahead and figure it out. It's okay if your k is a fraction. That's not necessarily a bad thing. So let's go ahead and figure it out. Remember, our form looks like y equals kx. So using a coordinate point, we can find the value of k. I'm going to replace the y with -3 and the x with -2. Replacing x and y into this will help me find k. And then we'll see, is it the same k for these other coordinate points? Let's see. So let's go ahead and replace the y. Like I said, the y with -3 equals k times the value of x. So that's -2. I can solve for k here by dividing both sides of the equation by -2. That gives us k by itself. Now we know the value of k. Notice it's -3 divided by -2. And a negative divided by negative is positive. So that's the same as +3/2. So that's here in this case, our k is 3/2 or 3/2. Let's see if it's the same for this second coordinate point. If it's the same for every coordinate point, then we know our value of k. So 2, 3. Again, I'm going to replace using this same thing, I'm going to replace the y value with 3 and the x value with 2. Remember, sometimes I write things in parentheses, like k parentheses 2 in this case. That means those things are multiplied. Whenever you see something right up against parentheses, that usually means that the two things are multiplied. So we would divide by 2 on both sides to cancel out the 2 here. That gives us 3/2 for k as well. Well, that's the same as right here, isn't it? 3/2. So we have the same value of k for both coordinate points. Is that going to be the same value of k for this last coordinate point? Well, it should be if it's direct variation. So let's go ahead and check. 6 equals k times 4. Let's go ahead and divide both sides by 4 to get k by itself. Here we have 6/4. Is that the same value of k? Well, yes, actually, because you could reduce this fraction by a factor of 2. Whenever you can reduce fractions, you should. In this case, we could divide both top and bottom by 2, giving us 3 over 2, same value of k, isn't it? So since we have the same value of k for all these, yes, our value for k is 3 over 2 in this case. Okay, let's go ahead and move on. I'm going to talk about some real world examples. On page 21, this is like the written activity. So go ahead and go to page 21 if you're not there already. We'll go over each of these questions and I'll explain them in full detail. If you want, you could try to do the questions on your own and then just come back to the video whenever you need help. Okay. Activity. Imagine that your theater club is preparing for an upcoming performance. The club is selling tickets at a rate of 3 tickets for $20. Answer the following questions about this situation. So the first thing is 3 tickets for $20. So one thing to keep in mind is that that's essentially a coordinate point, isn't it? That we have a coordinate point of 3, 20. Now, can we find the value of k given this point? Well, yes, we can, because remember, we could write it as y equals k times x. In this case, the value of y is 20, and the value of x is 3. So we could say 20 equals k times 3. Solving for k, we're going to divide both sides by 3. This gives us that the value of k is 20 over 3, or 20/3, you may call it. And there you go. This is the rate of change in this situation, or in other words, your k, or in other words, the slope of the direct variation line. What is the direct variation equation? Well, remember, it's y equals k times x, and we just determined the value of k is 20 over 3. Let's go ahead and finish filling out this x and y table using the value of k that we had found in the previous problems. So you can see here, 0 tickets costs $0. In other words, it's direct variation. It should go through 0, 0, right? Direct variation always goes through 0, 0. Also, 3 tickets cost $20. Well, we knew that already, right? They told us that. How much do you think 6 tickets would cost? Well, hopefully you could say, oh, well, that would cost $40, right? If 3 tickets cost 20, then 6 tickets cost 40. Another way to solve this is we already know our equation, y equals kx, and the value of k is 20/3. So y equals 20/3 x. Now, if we know the value of x is 6, we can find the value of y. So I'm going to go ahead and replace the x in this equation, the x, with 6. And then it'll help us find the value of y. Now, we already know it's 40, but let's just plug it in, and that way we can see the algebra behind it. So we're going to go ahead and replace the x, substitute it with the value of x, 6. So that'll be y equals 20/3 times 6. Now, how do I multiply a whole number times a fraction? Well, I've talked about this in just about every lesson. To multiply a whole number times a fraction, you multiply the whole number times the top and then divide by the bottom. So you multiply the whole number times the numerator, the top number, and then divide by the denominator, the bottom number. So 6 times 20 is 120. Then 120 divided by 3 gives you 40. And you could use a calculator if you're not good multiplying and dividing in your head. But yeah, 6 times 20 is 120. Divided by 3 is 40. So yes, we get that 40 there. Okay. Using that same information, we can go ahead and find the price for 24 tickets. Using this exact same equation, y equals 20 over 3 times x. But in this case, we're going to replace x with what? Well, replace x with the 24, right? So that's going to be y equals 20 over 3 times 24. That's a 3 there. Okay, now how do we multiply a whole number times a fraction? Again, you multiply times the top, divide by the bottom. So 24 times 20 24 times 20, 480. I'm using a calculator, as you can see, and then divide by 3. So 160. Okay, so the price of 24 tickets is going to cost $160. All right, hope that made sense. Now for this last answer we need to find, here they give us the value of y as 400. And our goal is to find, well, how many tickets will that buy? In other words, what's the value of x? So we're going to go ahead and use the same equation, except this time we're going to replace the y with the y value, 400. So let's go ahead and do that. So here, that's going to be 400 equals 20/3 x. Now, how do I get x by itself here? I want to solve for x. I want to get x by itself. How do I do that? Well, I'm actually going to move this equal sign a little bit. And by the way, if you do everything I do, it'll make a lot more sense. Write down everything I write, do everything I do. It'll make a lot more sense. And honestly, it'll be a lot less boring. So how do I get rid of this 20/3? One thing you could do is multiply by its reciprocal. So I'm going to multiply by 3/20. And what happens is that gets rid of this fraction. However, this side I would have to multiply also by 3/20. So that gives us x by itself here on the right. And then what's 3/20 times 400? Well, again, we take the whole number, 400, multiply times the top, then divide by the bottom. So 400 times 3 is 1,200, and then divide by 20. That gives us 60. So for $400, you could purchase 60 tickets. Okay, so make sure to fill in those answers here and move on. Plot 4 data points and the line of best fit on the graph to model the ticket sales and money earned for the club. So you can just use the coordinate points we found up here. So we know we're going to have 0, 0 is 1. We know for 3 tickets that costs 20, and for 6 tickets that costs 40. And we also know, how much do you think 9 tickets would cost? Well, that would cost 60, don't you think? Notice the points are all lined up. This is exactly what we should expect. The points are lined up and it goes through 0, 0, which of course makes sense because it's direct variation. Go ahead and create the line by clicking and dragging one point to the next. If your theater club sells 54 tickets, how much money will it earn? So again, I could use the same equation we had from before. That's this one, y equals 20/3 x. So I'm just going to go ahead and what we're going to do, instead the x value is going to be 54 because it's 54 tickets. So it's essentially like this again, except here we're looking for an x value of 54 and we want to find the y value. So treat it like another one of these problems essentially. So that would be y equals 20/3 times the value of x, in this case 54. To multiply a whole number times a fraction, you multiply the 54 times 20 and then divide by 3. So 360. And there you go. Let's go ahead and move on. I hope that made sense. If it did, then great. Let's go ahead and move on to the practice. And you're going to have 5 questions for your practice, but I'm going to go over 10, actually I think 10 questions here. And if you just follow along for all 10 of these, I guarantee you it'll make a lot more sense in the long run. Okay. Scott is driving to visit family. After 3 hours of driving, Scott traveled 180 miles. After 5 hours at the same rate, he traveled 300 miles. Which equation represents this situation? So for this one, we have a couple of coordinate points that they're giving us essentially. They're giving us 3, 180, as well as, I guess I don't need to do that. They're giving us 3, 180, as well as 5, 300. So 3, 180. And then also, they're giving us the other coordinate point in 5 hours of driving, 300 miles. One way to look at this is finding the value of k is simply 3 times something, 3 times some value k gives us 180. So 3 times what gives us 180? That'll tell us the value of k. So in this case, it's 3 times 60, isn't it? And there you go. 3 times 60 gives you 180. 5 times 60 gives you 300. So it's the same value of k for both, which is what we should expect with direct variation. Now, let's go ahead and move on to the next one. Emily is walking around her neighborhood. After walking 6 minutes, she has traveled 4 blocks. So this gives us one coordinate point. Just like the previous example, 6 minutes, 4 blocks. After walking a total of 15 minutes, at the same rate, she traveled 10 blocks. Okay, so once again, we're looking for the value of k. 6 times what gives me 4, or in other words, 15 times what gives me 10. Should give me the same answer either way. But if she walks a total of 30 minutes at the same constant rate, how many blocks would she travel? So now we're trying to find 30 comma what? I'm going to put y here. So the first thing I want to look for is I want to find my value of k. Once I know my value of k, my constant of variation, then we're able to use that value of k to help us find this y value here. So 6 times what gives me 4, right? So what's our value of k? Well, we could set up an equation if we're not sure. Y equals k times x, but we're going to use these coordinate points, 6, 4. So replace the x with 6 and the y with 4 to help us find k. So that's going to be 4 equals k times 6. Now, how would I solve for k in this case? Well, I hope you can see that I would divide both sides by 6 to go ahead and get k by itself. 4 over 6. You can reduce this fraction by dividing both top and bottom by 2. So you can reduce by a factor of 2 for this fraction, giving us 2/3 as a reduced fraction. And that's our value of k in this case. So can we use that information to help us find y in this case? Yes. Remember, we could write it as y equals k, which is 2/3, times the value of x, which in this case is 30, for this coordinate point. How do we multiply a whole number times a fraction? You multiply the whole number times the top, then divide by the bottom. So 30 times 2 is 60. 60 divided by 3 is 20. 20 blocks. And there you go. Let's move on. In which table does y vary directly with x? So a couple things we want to see is that it's multiplied by the same thing each coordinate point. So let's go ahead and look at this first list. 1 times what gives me 3? So what's the value of k? So 1 times what value of k to give me 3? Well, hopefully you know that one. That's 1 times 3. So for this first coordinate point, we could see that k would be 3. Is that the truth for this coordinate point as well? 2 times 3 gives me 6. Well, yes, that works there. So k is also 3 here. Is that true here? 3 times 3 gives me 9. Well, yes. So we're multiplying by 3 to go from the x coordinate to the y. We're multiplying by 3 each time. That tells me it's direct variation. Notice none of the other lists will follow that. Notice here it's times -3. 2 times -3, well, that doesn't work. That doesn't give me 0, does it? Here, 1 times 2 times 2. 2 times 2, oh, that seems to work. 3 times 2 to get 8? No, that doesn't work. So it's not the same value of k for each point. So we know that that's not right. Here, 1 times 4 to get 4. 2 times 4 gives us 5? Well, no. So you can see that only this list has the same multiplier across each x to y coordinate. Lance is selling strawberries at his local farmer's market. He sells 4 pounds of strawberries for $10, 8 pounds of strawberries for $20. So 4 pounds of strawberries for $10. And then the second coordinate point it gives us is that 8 pounds of strawberries for $20. Okay. Let's see which of these equations gives us the correct value of K. So we're looking at 4 times what to get 10, essentially. We could go ahead and write y equals K times X for our direct variation equation. So in this case, let's just go ahead and use this first coordinate point. Replacing the y with 10, let's go ahead and find the value of K. We replace the X with 4 in this case. We're using this coordinate point, see? Now, let's go ahead and solve for K. We would do that by dividing both sides by 4, giving us the value of K is 10 over 4. As a fraction, we can reduce this by a factor of 2. Remember, if you can reduce a fraction, you probably should. So 5 over 2 is our fraction here. Oh no, we don't see 5 over 2. But what we can do, notice these are all decimal values. One thing we could do is with our calculator, if we're not sure what a fraction is as a decimal, what we could just do is put the fraction into the calculator. So in this case, that's 5 divided by 2. So I'm going to put over in here 5 divided by 2, and I get 2.5. All right. So that tells me that the value of K is 2.5. That's the same as 5 over 2. Isabella is selling lemonade. She sells 6-ounce cup for $1.50. So we have the coordinate point 6, 1.5, and a 12-ounce cup for $3. So 12-ounce cup for $3. Okay. Which equation represents this situation? So again, my goal here is to find the value of X. So what's the multiplier here? 6 times what gives me 1.5? Or in other words, 12 times what gives me 3? Well, I'm going to go and use this second coordinate point because I'd rather not deal with decimals if I could avoid it. So this would be 3 for the value of y equals K times the value of X, 12. Let's go ahead and solve for K, and we would go ahead and do that by dividing both sides by 12 in this case. Canceling the 12 over here gives us that the value of K is 3 over 12. We can simplify this fraction by a factor of 3 in this case. Both of the numerator and denominator are divisible by 3. So let's go ahead and reduce it, giving us a fraction of 1/4. So kind of tricky. Is it this one or is it this one? Well, it's actually this one. This second one looks like it could be the right answer, but notice X is in the denominator. We don't want that. That would create a very different graph. Here we want this one. And if you're ever unsure, you could always graph it on Desmos, which is a graphing calculator. I suggest becoming familiar with this website, desmos.com. Whenever you want to graph something and you're unsure, you could always go to this website and it'll graph it for you. Whether that's linear equations or any type of equation, it'll graph it for you. It's a very powerful graphing calculator. So here's our function in this case. Next one. Emily is walking around her neighborhood. After walking 6 minutes, she's traveled 4 blocks. So we have a coordinate point here, 6, 4. After walking a total of 15 minutes, she's traveled 10 blocks. So the second coordinate point we have is that 15 minutes of walking, 10 blocks distance. Given that Emily walked the same pace the entire time, how long did it take her to travel 8 blocks? So essentially we're finding how much time does it take to travel 8 blocks? Okay, I could already see the answer. Can you? Well, let's go ahead and see. We know we can write the equation in the form y equals k times x. We could use this form to help us find the value of k we could use either of these coordinate points here to help us find k. I'm just going to go ahead and use the first one, 6, 4, replacing the x with 6 and the y coordinate with 4. So let's go ahead and do that. 4, replacing the y with the y coordinate, equals k times x. The value of x is 6 in this case. Let's go ahead and solve for k by dividing both sides of the equation by 6. Remember, whatever you do on one side of the equation, you have to do on the other. It's one of the primary rules you need to follow in algebra. Now, here we have 4 over 6. Can I reduce this fraction? Well, yeah, you can. You can divide both top and bottom of this fraction by a factor of 2 in this case, giving us the fraction 2/3. So that's our value of k. Now we can use this value of k to help us find x from this coordinate point. So it's going to be y equals k times x, but we know the value of y is 8, and we know the value of k is 2/3. So I'm going to rewrite this equation using that information. So that's going to be 8 equals, and I'm going to leave a little bit of space here. You're going to see why. 2/3 times x. Now, how do I cancel out the 2/3 in this case? Because I want to get x by itself. How do I get rid of that 2/3? Well, one way to think about getting rid of fractions is you can multiply by the reciprocal. In this case, 3 over 2. By multiplying by 3 over 2, that cancels the fraction. But that means I have to multiply by 3 over 2 on the other side of the equation as well. Remember, whatever you do on one side of the equation, you must do the exact same thing on the other side. So how do we multiply 3 over 2 times 8? Well, remember, when we're multiplying a whole number times a fraction, just multiply the whole number times the top, then divide by the bottom. So 8 times 3 is 24. 24 divided by 2 is 12. So that tells us the x value is 12. Now, remember when I said I already figured out the answer? Well, that's because if she can walk 6 minutes, takes her for 4 blocks, well, I know if I double the amount of blocks she walks, that'll double her time. And double 6 is 12. So anyway, a drugstore sells vitamins in bottles with different pill counts. The price of each bottle is shown in the table below. All right, so we got some number of pills and their prices. About how much does one vitamin cost? So one thing to keep in mind here, so let's just go and use one of these coordinate points. We'll just use the smallest one in this case. 50 pills costs $1.85. We could use the y equals kx to find the value of k. Once we know the value of k, then we can find this, how much does one vitamin cost? All right, so let's go ahead and do that. So I'm going to replace the y with the y coordinate. So I'm going to replace y with $1.85. And replace the x with the x coordinate, in this case, 50. Let's go ahead and solve for k by dividing both sides of the equation by 50 in this case, giving us k by itself on the right. And we can go ahead and use our calculator to find a decimal answer, 1.85 divided by 50. All right, it looks like I got 0.037. So in terms of money, that's about between 3 and 4 cents, essentially, but closer to 4 cents for one pill. Okay. Charlie is laying down mulch in his front yard. It takes Charlie 4 minutes to lay down 11 cubic yards of mulch. So 4 minutes, in 4 minutes, he can lay down 11 cubic yards of mulch. In 16 minutes, he can lay 44 cubic yards of mulch. Plot 5 data points and a line that represents the direct variation relationship. So we want to plot 5 points here. Well, I know it's direct variation, which tells me automatically it goes through 0, 0. Remember, with any direct variation relationship, we know it must pass through 0, 0. Now, they also give us a couple other coordinate points here, 4, 11, 4, 11, and 16, 44. So we already know what our line is going to look like. It's going to connect these 3 points together, right? Now, if it takes 4 minutes to lay down 11 cubic inches, 8 minutes, in 8 minutes, how much will he lay down? Well, hopefully you can imagine there that in 8 minutes, if I double the amount of time, he can do double the amount, right? And notice the points, they still all line up, right? That's key. All your points should line up. And 12, in 12 minutes, he's likely to be able to do 33. So there's your 5 points. Then you want to go ahead and use the ray tool. Click here and then drag to the next point. It should create a ray that looks like this. Make sure the arrowhead is on this side. Okay. Consider the given graph. So here we have a line here. And is this line direct variation? Well, yes, it is. Because remember, the 2 requirements for direct variation is that 1, it's a line, which it is, and 2, it has to go through 0, 0. And in this case, it does, right? It goes through 0, 0, and it's a line. So it is direct variation. So which equation represents this direct variation? Well, we basically need to find the slope of this line. To find my slope, I could use this first point, 0, 0, and I can find the next, look for the next point that's on the grid lines. So when I'm calculating slope, I always look at the grid lines and I want to find a point that's on our line, but also on the grid lines. So you can see that like right here. It's easy to see that what this point is. The reason I pick a point that's on the grid lines is because it's easier to count to it, right? Like if I pick a point here, it's not quite on the grid lines. I don't know how much I'm going down, how much I'm going over. It's hard to tell. But with this point that I picked right here, it's easy to count to it. You can see that there. So what's our slope here? What's the rise over run? In other words, what's the value of k? Well, it goes down 2. So since it's going down 2, I know it's going to be a negative slope. Down 2 over 1, 2, 3. So our slope in this case, or the value of k, is negative 2/3. So I know that this will be our equation. I want to also point out that if your line is going downwards as you go from left to right, if it's going downwards, that tells you it has a negative slope. So this one for sure is going downwards as you go from left to right. So that's going to be a negative slope. Let's go and do the last one for the practice. Which graph represents direct variation? I'm pretty sure you could do this one on your own, but 2 things to keep in mind. It needs to be a line and it needs to go through 0, 0. So let's see which of these answer choices follows those 2 criteria. Well, this one does not, because even though it's a line, it doesn't go through 0, 0. This one's also a no. This one's also a no. This one is a yes, because look, it's a line and it goes through 0, 0. So that tells me that that's direct variation. Okay, now let's go ahead and move on to the mastery test. And by the way, if you're not subscribed already, please go ahead and click that subscribe button. It's an easy way for you to say thank you to me for all the hard work I put in. You can see how many videos I put in to help you guys, but if you could just subscribe, it allows me to continue to do this, and it also helps me out a lot. So thank you for doing that. Let's go ahead and move on to the mastery test. I have 20 questions here I need to go over, but you're only going to be given 5 questions. So you'll be given 5 questions out of these 20 questions. So I will at least give a hint for every question. And if there's any questions that I feel are extra hard or just not fair, I'll just go ahead and do the full answer for you. But if you follow along with me for all 20 of these questions, even though you don't have 20 questions, you'll get the fullest out of the lesson and it'll make the most sense. I know it takes time, but if you really want to learn something and get good at it, just like with anything else, it takes time and it takes practice. So let's go ahead and get started. Amir is starting a stamp collection. After 3 weeks, he has collected 35 different stamps. After 9 weeks, he has collected 105 different stamps. What is the constant of proportionality in this direct variation? So we have a couple of coordinate points, 3, 35. So 3 weeks, 35 stamps. And we also have another coordinate point, 9, 105. So you don't need 2 coordinate points in this case, but since they already told us it's direct variation, so you could write it as y equals k times x for any direct variation. Now what you can do is, now you just need to find the value of k. And you would do that by replacing you could use either coordinate point, but I'll just use this one. Replace the y with 35 and replace the x with 3 and then solve for k. So your goal here is to solve for k. If you're not sure how to do that, go ahead and look at the examples in the practice earlier in this video. In which of these does y vary directly with x? Well, if it's direct variation, that means it should be the same multiplier of k to go from the x values to the y values. So in this, I could take a look at any of these examples and we'll just look at A, and actually A is wrong, so don't click that. But I'll show you why it's wrong. Notice 1 times what gives me 3? Well, 1 times 3 is 3, right? Now, is that the same for here? 2 times 3 gives me 9. 2 times 3 is 9. No, that doesn't work. So it needs to be whatever value you got for this one needs to be the same for this one, needs to be the same for this one. So if it's the same multiplier for each going from x to the y coordinate, then you know that's the correct one there. Okay. So this next one's a little bit tricky, but if you take a look, let's see, number 3. Caroline is planting flowers in her garden. She plants 7 flowers in 4 minutes, and after 12 minutes, she has planted 21 different flowers. Which equation represents direct variation? Well, here it's not very clear what the x variable should be and what the y variable should be. So in general, we want to usually consider time as our independent variable, because time runs independent of other things. The number of flowers, however, depends on the amount of time. So here, our x variable is the number of minutes. So our first coordinate point is 4, 7. I know they list the 7 first, the 7 flowers, but keep in mind that in general, you want your time to be your x coordinate if time is one of your variables. And also it doesn't directly say which variable is which, in which case we usually want to consider time to be our independent variable, the x variable. All right, so then our second coordinate point is 12, 21 in this case, because after 12 minutes, she planted 21 plants. So let's go ahead and find our k. Remember, we can set the form for direct variation, y equals kx. And in this case, you could use either coordinate point to help you find k. And I guess we could just use this first coordinate point. So it'd be 7 equals k over, or k times 4. Go ahead and solve for k, and that should tell you which equation is the correct answer. Okay, let's go on to the next one. Caroline is planting flowers, so it's the same situation. 7 flowers in 4 minutes, so 4, 7. After 12 minutes, she has planted 21 flowers, so 12, 21. If Caroline keeps planting flowers at this rate, how long will it take her to plant 70 flowers that she has? Okay, so first we could think about y equals kx because it's direct variation, and we could use either coordinate point. Let's go ahead and use the smaller numbers. So for this one, we would say 7, replace the y with the y coordinate, so y with 7 equals k times the x coordinate, which is 4. Let's go ahead and solve for k, and the way we're going to do that is divide both sides by 4. This gives us the equation y equals 7 over 4 x. Now, how long will it take her to plant 70 flowers? So 70 flowers, that's the y coordinate. The number of flowers is the y coordinate. And what you're going to do is you're going to replace y with 70, and we're going to solve for x. Okay, so we have 70 equals 7 over 4 x. Notice I'm leaving a bit of space here. And the reason why is because I like to leave a little bit of space to multiply this side by the reciprocal of the fraction. So you could always get rid of a fraction in any equation, get rid of a fraction by multiplying by its reciprocal. So I'd multiply the other side as well by 4 over 7. This cancels this. So go ahead and multiply 4 over 7 times 70 to figure out the answer. Amir is starting a stamp collection. After 3 weeks, he has collected 35 different stamps. So 3 weeks, 35 stamps for Amir. After 9 weeks, he has collected 109 stamps. So 9 weeks, 105 stamps. Which equation represents the direct variation? So it's very similar to the ones we just did, but you're going to write it y equals kx. And you could use either coordinate point to help you find the value of k. I could just use this first coordinate point, replacing the y with 35 and the x with 3, and go ahead and solve for k and plug it into here to find the correct equation. All right, here's the same situation. It's the same coordinate points as well, right? 3 weeks, 35 different stamps. After 9 weeks, 105 stamps, 105 stamps. How many stamps will I have after 15 weeks? So we can go ahead and find the equation. So y equals kx, again, for direct variation. And we're going to use this, you could use either coordinate point. So I'm just going to use the smaller numbers. Replace the x with 3, because that's the x coordinate. Go ahead and divide both sides by 3 to get k by itself. By the way, I hope you're following along and writing everything that I write. So that gives us the equation y equals 35 over 3 x. So this is our direct variation equation. Now, how much will you have after 15 weeks? So what you're going to do is replace x with 15 to help us solve for y in this case. So I'm going to replace the x with 15 and solve for y. Now remember, how do you multiply a whole number times a fraction? You multiply the whole number times the top and then divide by the bottom. Okay. While on the road trip, Steve drove 300 miles in 5 hours. After stopping for gas, he drove an additional 120 miles in 2 hours. Does the situation represent direct variation? If so, what are the independent and dependent variables? Okay, let's see. So we're going to say 5, 300. Okay. Notice I'm putting time as my x coordinate. Generally speaking, you want your time variable to be your independent variable, the x coordinate. So we have 5, 300 and 2, 120. All right. So let's see. Is there a multiplier to go to here? So 5 times what gives me 300? So what I could do is use my calculator, and I can do 300 divided by 5. So I know that it's times 60. So 5 times 60 gives me 300. Is it the same thing here? Is it times 60? Well, yes, it is. 2 times 60 for 120. So since it's the same multiplier, then yes, it would be direct variation in this case. Okay. And what thing would be the independent variable? Do you think it's the time or the distance? So see if you can figure that out. Autumn had a math homework assignment each day last week. Each assignment had a different number of problems and took her a different amount of time to complete as shown in the table. So 8 problems took her 16 minutes, 15 problems took her 30 minutes, and so on. Seems to be direct variation here. What is Autumn's rate of change in time in minutes with respect to each math problem. So in other words, what are we multiplying? What's our K, our multiplier, to go from here to here? It should be the same multiplier to going from each step, and that should tell you the answer. The distance a bike travels varies directly as the amount of time the bike has been ridden. Angela is riding her bike. She travels a distance of 60 miles in 2 hours. So we're going to say 2 hours, comma, 60. Notice I'm putting time as my X variable, the independent variable. Generally, time is our independent variable. What would be the second coordinate point? How far has Angela traveled in 7 hours? So 7, comma, something, right? I need to find this something. Put a question mark there. Okay. So one thing to think about is what's the multiplier here? 2 times what gives me 60? And then that same multiplier to figure out this, okay? So whatever that K multiplier is, that'll tell you what to multiply this by as well. The weight of a box varies directly as the volume of the box. If a 300-pound box has a volume of 23 gallons, what is the weight of a box that has a volume of 25 gallons? Okay, so 138-pound box. We're going to write it the other way, where the gallons will be the independent variable. So 23 gallons weighs 138 pounds. What about a 25 gallon? Well, what's the multiplier here, right? Whatever the multiplier is here, that's the same multiplier here, okay? Because it's direct variation. Now, how do I find what K is there? Well, you could think about the equation y equals kx, right? So in this case, that would be 138 equals k times 23, right? Go ahead and divide both sides by 23 to find k. Once you know k, you should be able to figure out what this is. The number of calories needed in a daily diet varies directly with the weight of an individual. If 1,050 calories should be consumed by a 105-pound person, so we could say 1,050 calories for a 105-pound person. What is the weight of an individual who consumes 1,370 calories? So we need to know what's their weight in this case. So once again, like we've solved with other ones, set it up as y equals kx using this first set of coordinate points. So that would be 105 equals k times 1050. Go ahead and divide both sides by 1050 to find k. Once you know k, then you know what multiplies to get to here. The cost of a company picnic varies directly with the number of employees attending the picnic. If a company costs $487.50 for 30 employees, so I'm going to put the employees as our independent variable and the cost as the dependent variable. It doesn't matter, honestly, too much how you set it up, but what does matter is that, notice it's 30 employees. I'm choosing that as my X variable. So when I see 80 employees, that's got to be the X coordinate as well here. So go ahead and find this, what this is going to be. So whatever the multiplier is here, so 30 times something gives me that. So some value K, it should be the same multiplier here. Okay, because it's direct variation. The number of word types typed varies directly as the time. 300 words are typed in 6 minutes. So I'm going to have my time be my X coordinate because usually time is your independent variable. So in 6 minutes, 300 words are typed. How many words can be typed in 17 minutes? So these are all, the last few questions are all very similar. So what's the multiplier? So 6 times what to get 300? then you'd use that same multiplier to figure out what this is. Okay. The number of wrecks at a certain intersection varies directly as the number of cars that travel through the intersection. If there are 31 wrecks when 1,085 cars have traveled through the intersection, how many cars have passed the intersection with 7 wrecks? So 31 wrecks cause 1,085, or 31 wrecks were caused by 1,085 cars driving through. So 7 wrecks, how many would that be? So once again, what's the multiplier? What are we multiplying by to get to here? That's your value K. Then you multiply the same amount here. Okay. The price of tiling a room varies directly as the size of the room. Sam is laying tile in his kitchen. If the tiling costs $4,224 for 264 square feet, what's the size of a kitchen that costs $3,824? So we're going to do the square footage, so 264 as our independent variable, and the cost depends on that. So we would say like this. Okay, so here we don't know the size of the kitchen here, but we do know the cost, right? Now I could have said it the other way, and that perhaps would be simpler, but it doesn't really matter too much. Because here I can find the multiplier, right? So what do I multiply by to get this? Well, then I divide, right? 4,224 divided by 264. 4,224 divided by 264 gives me that K is 16. So the multiplier here is 16, right? Times 16. So X times 16 gives me that. Well, to go back the other way, you divide by 16. That's not a decimal, that's a multiply there. Same here, it's a multiply. Yeah, so instead of multiplying 16 to go from left to right, to go from right to left, you divide by 16. So there you go. The number of oranges purchased varies directly as the price of the oranges. 11 oranges cost $2.35. How much would 18 oranges cost? So 11 oranges cost $2.35. How much would 18 oranges cost? Now, right away, I can see, okay, well, this is not a correct answer, and this is not a correct answer, right? It's not going to be in the 80s of dollars, right? But what do we multiply by? What's the multiplier here to go from 11? So times what gives me 235. Whatever that multiplier is, you multiply the same thing over here, times K. Which graph represents direct variation? Well, remember, the couple things we need to look for direct variation is it needs to be a straight line and it needs to go through 0, 0. So that's what you're looking for, a straight line that goes through 0, 0. Okay, number 18. Caroline is planting flowers in her garden. She plants first 7 flowers in 4 minutes. Okay, so this is the same scenario we saw before, right? 4 minutes for 7 flowers. And then 12 minutes for 21 flowers. Okay. Plot 4 data points on line of best fit to model how long it takes for Caroline to plant flowers. Well, since we know it's direct variation, we know it'll go through 0, 0, right? Which makes sense. To plant 0 flowers, it takes 0 time. Okay. We also have these 2 coordinate points they already gave us, 4, 7. So 4, 7. And also 12, 21. 12, 21. Okay, so we have 3 coordinate points already. What would be a 4th point that we could use? Like, how long would it take? If it takes 4 minutes to plant 7 flowers, how many flowers can I plant in 8 minutes? Okay, and then keep in mind that the points should all line up, and then create the line. The line should connect all 4 points. So you need to create a fourth point and then also create the line connecting all 4 of those points. Next one, number 19. The weight of a bag of golf balls varies directly as the number of golf balls in the bag. If a bag of 69 golf balls weighs 2,553 grams, so we have a coordinate point, 69 golf balls, 2,553 grams. How many golf balls are in a bag that weighs 1,110 grams? So how many golf balls to weigh 1,110 grams? Okay, so one thing to think about is 69 times what gives me the 2,553. So times what value of K? So whatever value you find there, what multiplies to give me this, then you would divide by K here to go backwards, right? Divide by K. So 1,110 divided by the same value K you got here should give you the number of golf balls. Okay, now how do I find this K here? Well, since I have this coordinate point, it's easy to find. I just do the 2,553 divided by 69 to get K. Once I have K, do this to find the number of golf balls. The number of goals scored by a soccer team varies directly as the number of shots on goal. If the Lakeside Bears scored 4 goals after 48 shots on goal, okay, so 4 goals after 48 shots on goal, how many more shots on goal should the team take to score 3 more goals? Okay, so if they want to score 3 more goals, how many shots on goal do they need to take? So again, figure out the multiplier here times K, and then here times that same K going there. Okay, well with that, I hope that made sense. Hope you're able to get through it, and like, comment, subscribe for the algorithm, all that. Anyway, I'll see you next time. Take care of yourselves.